now you're gonna see where, like, why do we do z-scores? Like, why do we calculate the z-scores of something? Okay. So we used to only talk about normal distribution. Now we're gonna introduce standard normal distribution. And what does that entail? Okay. We're gonna use z-score to compare data from different sets. Right? So the classic is, it's not just test scores, but let's say there's two students here. Jay's final score in his class is 70%, with a class average of 75 and a standard deviation of 5%. Jasmine's final score was 60%, a class average of 65, a standard deviation of 7, right? So there's two students, different classes. So we're gonna graph a normal distribution curve for both of the classes, okay? So we're gonna have Jay over here and Jasmine over on the other side. And let's try this. I tried to make this work. This is where the mean would be for J, and that's 75. And we're going up by 5%. So this would be 80. This would be 85. This would be 90. So just count five slots. That's kind of how I intended it to be. And then we're also going to go down. This will be 70, 65, 60, right? And obviously this is percent. So in this, if they're normally distributed, we would have, in Jay's case, we go up 75, right? We make our dot there. And we draw our bell curve like so, where 75 is kind of like the highest. I need to adjust this a little bit. Doesn't seem like, maybe something like that. And Jazz is on the other side here. The average is 65. So let's find the middle. I think this is the middle right here. And we have 65 there. And that standard deviation is 7 for her class. Okay, standard deviation is 7. So we're going to count 7 marks. So 2, 5, 6, 7. Today is day 6-7, guys. Happy 6-7. Anyways, that's not even a thing. That's not even a thing. But anyways, keep counting 7. 1, 2, 3, 4, 5, 6, 7. That would be 79. And we could continue on a little bit. Let's see if we can make this work. 1, 2, 3, 4, 5, 6 would be here. 7 would be out here. That would bring us to 86. Okay, all the way to 86. 7, subtract 7, so this is 5, 6, 7 here. That would put us at 58. 1, 2, 3, 4, 5, 6, 7. That would put us at 51. 1, 2, 3, 4, 5, 6, 7. I have to add another line here. That would put us at 44. And again, this is not, it's not crucial. This is not about the graph necessarily. We could have had them both on the same, but I wanted them separate. Between the two bell curves, which one is going to be flatter? The one that has the, yeah, Jazz, because it's a bigger standard deviation. It's more spread out. So we're going to just kind of use this as a reference, and we're just going to make sure we're a little lower. Okay, so those are both of the classes. And now I'm going to use a red pen and say, like, let's pinpoint exactly what their average was. So Jay's final score is 70, so that's Jay right there. Okay. Jasmine's final is 60. 60 is right there. That's the 60%. We can go over to J and say that's 70% right there. And how about just by observation already, if you pinpoint both of there, which one seems to be closer to the average, to the mean? J or Jazz? It's maybe hard to see, but we'll find out for sure, okay? So the idea is to see, let's say they have an argument like, well, you got a 70, Jay, so you did better overall. You're the better student, quote unquote, right? The reality is it depends on, it doesn't necessarily, is not necessarily true, because it has to do with the average and the standard deviation of that class. Because it could be that Jay had a teacher that was a little easier going, maybe gave some bonuses on some freebies, right, and that brought the mark up. And Jazz's teacher is like no bonus, nothing, right? It's just test, that's it, right? So maybe he was a bit more rigorous. And so this is what we do. We calculate the z-score of each student. That's what we're going to do here. So z-score for J. For J, it would be, remember the formula? I hope you have that on your study sheet. That'd be 70 minus 75 divided by 5. That ends up being -1. Oops, you can't see that, my bad. Move the camera. So J, this is J, right? J is 1 full standard deviation below the mean. Okay? And then Jazz, we're going to go, her average was 60. The mean is 65 for the class. The standard deviation is 7. And we find out that it is negative 0.71. And this is when you look. This is when you know, you can truly compare and remove biases, so to speak. So you're going to ask yourself, when it comes to test scores, which one would you say did better? Jazz, right? Because she's higher up along the x-axis, right? She's closer to the mean, okay, in terms of the score. So in this case, you would say Jazz has done better. So what ends up happening when you turn both of their scores into z-scores, that means that we can now graph this under a standard normal distribution, okay? What is a standard normal distribution? It only has the z-scores along the x-axis. So basically, is that good? There we go, you can see it. So basically, we find the middle, and we put a 0 there. And I'm going to count every 5 marks and just put a 1, and then 2, go up by 1, right? And this would be -1, -2, -3. And then we go 0 is the center. That's where our average is going to be. And along the x-axis, we're just going to say z-scores. And now we can place them both along this one, right? So we know that this one would be J. Well, let's go up top like this. This is J. And Jazz would be, this would be 0.2, 0.4, 0.6, 0.8. So somewhere in here. Jazz is doing a little bit better. Okay. So even though she had a lower average final score, actually, if you compare and we use our z-score to compare, it ends up being that she actually did better overall. Okay? So we're going to make our conclusion here. Since we are considering final scores, a higher, let me just zoom into this, a higher z-score is more desirable. Jasmine's final score was lower than Jay's, but the z-score tells us that Jasmine did better. Okay, so that's why z-scores are helpful. Okay. When it comes to sugar intake, would you want to be on the higher z-score or on the lower z-score when you compare different people? You would want to be on the lower end, right? So it's not always like, oh, bigger z-score better. It's dependent on the situation, right? On the context. So you got to read carefully. But z-score standardizes everything, okay? That's it.